Hello everyone, welcome to Codeforces Global Round 170, which was a Division 2 contest. And in this contest, my Stride Breaker account became expert, so it's a small achievement for me in this winter arc. So yeah, let's go to the discussion of the questions. So starting with the first question, which is called two screens. This is a pretty simple question. In this question, we are given two strings S and T, and essentially these are the two strings that we are given in the input, and we are asked uh, and in every second this is the following thing we can do. We have two screens, and in every second you can either take a letter and write it, and take a alphabet and append it to one of the strings on either of the screen, or else what you can do, you can copy the content of one screen into the other screen. These are the two operations we can do. So the task is the minimum number of operations, or minimum number of seconds required to minimum number of seconds required to such that the screen 1 displays string S, screen 2 displays string T. So this is a pretty simple question. So how we'll do it, for both the string, in both the string, find the common prefix. Common prefix. Suppose the length of the common prefix is C, and the length of first string is small s, and the length of second string is small t. So what is the minimum number of operations required to do this? So this will be s plus t minus c plus 1. So where are these operations coming from? So the total number of time required to write s will be s, total number of time required to write t will be t. We are removing c operations because the common subsequence we don't need to type it again, and one additional for the copy operation. The only place the value of this will be s plus t when c is equal to 0. If there is no common sequence, then the length will be s plus t only. So yeah, these are the two cases that will be there in this question. Okay, moving on to the next question, which is called binomial coefficients, kind of. So question number B, binomial coefficients. Kind of. So in this question, the person, while calculating binomial coefficient, writes the formula of C of nk is equal to C of n comma k minus 1 plus C of n minus 1 comma k minus 1. Instead of the person uses this formula instead of the actual formula. Instead of this actual formula. Okay, wait a minute. N minus 1 comma k, and yeah. Okay. Instead of this formula, the person uses this formula. And now we are curious to find out what will be the. So we are given some. We are given an integer t, and we are given two space separated list of numbers, n1 n2 up to nt, and k1 k2 up to kt, and we have to find the values of c of ni comma ki for each of for I belong to 1 to t. So how will we do this? So one of the major observation is when you try to calculate these numbers, so we know that c of 0 0 is equal to 1, c of 1 0 is also 1, c of anything comma 0 is 1. So that we'll do. And when we try to calculate c of c of 1 1, so c of n comma k is c of n comma k minus 1, and c of n minus 1 comma k minus 1. Essentially this sum of digits which occur to the left and to the top left of the number. So essentially this summation will be 2 over here, and it will be 2 for each of and this summation will be 2 for every each of the number of the form c of I comma 1. For all these number, this value will be 2. For any number of the type c of I comma 2, this number will be 4. So if you see the pattern, the value of c of I comma j is essentially 2 to the power j. So we just have to print 2 to the power j modulo the large number, that is 10 raised to 9 plus 7. So this is just a simple function. You can do it either by binary exponentiation, or in Python we just have this function power, which power function, which allows you to take uh, we can just write two which takes 3 argument, the the base, the index, and the modulo. So this will calculate the value efficiently for us. Moving on to the next question, that is the new game question. So question number C is new game. In this question, we are given n cards, and each card has some value value written on it, a1 a2 up to an. Okay, and what we are supposed to do in this question is, so we have this person called Monocarp. What he can do is he can pick any card. He can pick any card at the beginning, and then he can pick say X. He can pick any card which has X written on it, and then on the next turn he can either pick a card which has X written on it, or he can pick a card with X plus 1 written on it. And he can only he is only allowed to do this as long as so once you pick the card, you discard it from the deck. And the other thing is, if you pick the next card, if you pick and you are only allowed to pick distinct card if and only if the distinct number of cards are no more than k. So in our input we are given n and k, and n different cards with the number ai written on it. So how will we do this question? So the simple thing is, we'll first sort the array that is given to us. So I will take an example. So suppose the first sample input. This is given to us. Now when we sort this, we get 2 2 3 3 3 4 4 4 5 and 5. Okay, and in this case the k is equal to 2. So obviously the optimal answer is picking 3 first, then picking all of the 3s and then all of the 4s. Okay, so how to solve this question? So this is very simple. First we'll sort the arrays, and then we'll make 2 different arrays called numbers and frequency of that number. So the numbers that are available to us are 2 3 4 and 5, and the frequency of them are 2 3 3 and 2 respectively. And now we'll use two pointer method to solve this question. So we'll initialize the pointer at both at the initial number, and if the so the second pointer b, so the right pointer bi, let the right pointer be j and left pointer be I. So if j minus I is greater than k, then we'll increase I by 1. Okay, if this is the case, then we'll increase I by 1. Otherwise, if j minus I is less than equal to k, if this is the case, then we'll check whether the integer at I, so number at j should be we should be checking that number of j should be if the number of j is equal to number of j minus 1 plus 1, then this is the valid increment in j. If this is not done, if this is not there, then we can clearly say that we can clearly increment I to j. I will write the cases more properly. I'll write the cases once more. So to write the cases, so if we know that I minus j plus 1, that essentially I minus j plus 1 is the number of distinct number we have is greater than k, then we have to increase, okay, not I minus j, j minus I, j is a right pointer, so we'll increase I by 1. If this is not the case, which means j minus I plus 1 is less than equal to k, in this case, we'll check that if the number at j is equal to number of j number at j minus 1 plus 1, if this is the case, then this is a candidate for our answer. So essentially the answer for this will be the prefix sum, basically the sum from ith index to jth index. So we'll maintain a prefix sum array to calculate this sum efficiently. So number of j is equal to number of j minus 1 plus 1. If this is the case, then this is a candidate for answer. But if this is not the case, that number at j is not equal to number of j minus 1 plus 1, so in this case, this is not an candidate for answer. The next valid candidate for answer will be when I will be incremented to j. So in this case, we'll increment I to j. And how will we calculate the candidate for answer? That will essentially be prefix sum of array of the prefix sum of frequency array from j to I. That will be one of the candidate for the answer, and we'll pick max between answer and the prefix sum. So this was and then we'll print the overall global answer. So yeah, so this was question number 3. And moving on to question number 4, which was actually an easy question which I was able to solve during the contest, but I got a time limit exceeded error. So I wrote, since I write all my contests in Python, I wrote this same question. I wrote the exact same code for this question in C++, and somehow it got accepted. Then I tried to figure out what the problem was, and I actually figured out the problem was the memory, due to the memory. So I will explain, I will show the code to it where it went wrong, but first let's focus on the question. So this is called attribute checks. So in this question we are given an integer n, an integer m, and next line contains n integers a1 a2 up to ai, and each of these integers are restricted to be between each of these integers are between minus m to m. Okay, so what does this mean? So essentially in this question we are playing a game with two attributes, strength and intelligence, and the integers which are given to us, the integers that are given to us are essentially an order in which we are going to face certain checks. So if our integer is equal to 0, at this position we can give one point to either strength or intelligence. If ai is less than 0, this means this is a if ai is less than 0, then this is a strength check attribute. This is strength check. So if at this point our strength is greater than absolute value of a of I, then we greater than equal to the absolute value of a of I, then we pass the strength check, else we don't. And if AI is greater than 0, then that's an intelligent attribute check. And if our intelligence is greater than A of I, we pass that attribute check. So, and now, since we are given the sequence, we can only check our whether our attribute is correct or not. We can only check our attribute. We can only increment our attribute when you encounter a 0. Now, one thing to notice in this question, that m is of the order uh, m is at most 5000, and this is the key where we have to this is the key to our problem. So I'll just try run a simple example of this question. So we are given 10 comma 5 and comma m, and then we have the attributes 10 then we are given the 10 records. So those are 0 1 2 0 2, okay, sorry, 0 2 0 minus 3 0 minus 4 0 minus 5. So to get the maximum benefit, it will be wise to put all our attributes into the strength. It will be wiser to put all our attributes into the into the strength bucket, and then if we put all these attributes, so this into the strength. At this point, if we have strength equal to 3, we'll cross this guy. Then at this point, we'll have strength equal to 4, we'll cross this guy. And at this point, if we have strength equal to 5, we'll cross this guy. So essentially, it will be wise to have strength equal to 5 to cross 3 attributes. Okay, but now the question is, how are we going to calculate the maximum strength that we need to pass? So here's how we'll go about it. So first of all, we'll maintain dp of I comma j tells us that dp of I comma j tells us that with strength equal to with intelligence equal to I and strength equal to j, with intelligence equal to I and strength equal to j, what is the maximum number of attributes you can cover at the point where we encounter. So dp of I comma j is maximum number of records you can pass if intelligence equal to I, strength is equal to j, at the I plus jth occurrence of 0. Now, why did I do this? Why did I frame my DP like this? Because now we know that there will be at most 5,000 zeros. Okay, there will be at most 5,000 zeros, because at most I have many zeros. So the size of a DP table is order of m square. Okay, so we need m square, and now let's see how much time is required to calculate each DP entry. So to calculate DP of ij, we'll need, so how can we obtain intelligence I and strength j? It can be obtained from the previous occurrence of 0, such that dp of at that stage we have intelligence equal to I minus 1 and strength equal to j, or intelligence equal to I or strength is equal to minus 1. So to calculate every entries, we'll need the previous 2 entries plus we can reach this state I comma j from I minus 1 comma j or I comma j minus 1. We can reach from 2 states, but with this we need to add that with this attributes, how are we going to cross the next section. So essentially we encounter our first 0, then we have some attributes check section, we encounter a second 0, we have the next section. So if at this position we have I comma j, then from this section we need to find out what is the number of what is the number of attributes check will cross in this section if our intelligence was I and strength equal to j. And now this depends upon what are the numbers that are present over here. So we need, and since m is of order 5 into 10 raised to 3, m square itself becomes 25 into 10 raised to 6, which is very very tight. This is of order 10 raised to 7, which is very tight. So we need to we can't spend log n time on this, so we need to do this very efficiently. So for this, what we are going to do is we are going to maintain two-dimensional array, position of m plus 1 into m plus 1, positive and negative of m plus 1 into m plus 1. Now what these arrays will do is so position of, so we'll go across, we'll traverse through x, we'll traverse through our array A, or the record array R, and what we'll do, and we'll maintain an index which is at 0. And what we'll do, whenever we we'll maintain an index which is equal to 0, and whenever we encounter attribute whenever we encounter ai equal to 0, we increment index by 1. If ai is greater than 0, then what we'll do, we'll increment positive, we'll initialize both these arrays to 0. We'll first initialize both these arrays to 0, and whenever ai is greater than 1, then what we'll do, we'll increase this entry by 1. Okay, and wherever we increment a negative number, we'll increment this index. Note the fact that I'm using a minus over here. We'll increment this index by 1. And now when we take the prefix sum of both position of both the two-dimensional array of position of I and positive of I and negative of j, if we take I comma j and negative of I comma j, if we take the, okay, what I'm going, we'll first calculate these entries. Okay, we'll after traversing a, we'll update this entry, and for every index so for every positive index will be an array, we'll take prefix sum of every such array, and for every negative index we'll take prefix sum of every such array, and from that what we are going to find. So now positive of idx comma j will tell me that in the idx section, in this section, if I have j, if the value of my intelligence for j, how many records will I be getting correct. This is what this thing will tell me after I do this procedure, and then I take the prefix sum over all rows, then this is what I'm going to get. And similarly, negative of idx comma j will tell me that in the idx section, remember that by section I refer to section between two zeros. So idx of j will tell me that if my strength was j during idx, how many records will I pass. This is what it will tell me. So now the dp is simple. So dp of I comma j is equal to max over dp of I minus 1 comma j plus positive of I minus 1, positive of I minus 1 plus negative of I dx comma j, and dp of this is one thing, and dp of on the other end, uh, the other entry that could be dp of I comma j minus 1 plus positive of I plus negative of j minus 1. So essentially there are two ways you can reach this value. One is from I minus 1 comma j or I comma j minus 1, and we take the maximum of both of these values, right? Okay, so this is how we'll do it, and in the end we'll return maximum over all ij's such that I plus j equals to m, or say m plus 1, because there's some adjustment you need to do, but essentially our answer will be max or all dp of j such that ij is equal to I plus j equal to m plus 1. So I will now show the code for this question. So this is my code for this question, and so this is just the simple input standard. This part is just my standard input thing. Here the thing start. So here I took the input. I defined the arrays positive and negative as mentioned in the previous part of the video, that is the two-dimensional arrays, and declared it as m plus of size m plus 1 and m plus 1 by m plus 1. And here I take the procedure where whenever I encounter 0, I just increment the index by 1, and if I encounter a number greater than 0, I increment that in a position matrix, and another I increment in positive matrix and negative matrix. And now in this for loop I am essentially taking prefix sum. And here is something smart that I done. So if you notice that to calculate dp of I comma j, I need only you need to calculate all the dp of I comma j such that I plus j is equal to some k. I will only need dp of I minus 1 comma j or dp of I comma j minus 1, and in this case I plus j minus 1 will be equal to k minus 1. So at a moment I will only need m plus 2 size of m plus 1, or rather order m size of dp table, so I can maintain 2 of such dp table. So if you can see, my previous submissions got memory limit exceeded because I wasn't using this optimization. And finally I use this two different arrays, previous dp and current dp, current dp to fix this. So essentially what I did, so current dp I just need previous dp, current dp I need previous dp. This essentially tells us that if I have b intelligence, then if I have b intelligence, then I can have either b minus 1 intelligence earlier or b intelligence now. So that is what I did. So, and in the end I just copy the current row into the previous row, and then again solve for the current row, and in the final step I just take max over all the final current dp module. Yeah, so that's it for today, and this is a very important thing that I learned because it optimizes my space significantly. And as you can see, my memory limit was just matched and my answer got correct. So yeah, that's it for today.